All right, so this is the thinking review questions on vascular contraction of the arterioles during causing hypertension. So let me orient you to this slide. We have what's happening in the kidneys, so the kidney slide. We have what's happening here in the arterioles, so the arterial slide. Here are the questions. I put the questions down here. Here's the result in the blood pressure, and then here's the rationale. So when it refers to the kidney slide, you see kidney slide, that's referring to this slide. Anything that talks about the arterial slide, you're going to be talking about focusing on this particular slide. The idea with this thinking review questions is you should be able to make the connection to what's happening in the kidneys with sodium reabsorption or less sodium reabsorption and the effect it will have on the arterioles and particularly vascular contraction and blood pressure. So trying to connect what's happening in the kidneys to what happens in the arterioles. So the first question is, what would happen to blood pressure if you increase angiotensin II? Well, you have an increase in blood pressure. And the reason for that is that increased angiotensin II is going to cause an increase in the sodium hydrogen exchanger 3, causing an increase in the uptake of sodium into the renal tubular cell wall and eventually into the capillary blood due to an increased activity of the sodium pump. Well, then what's going to happen is that increased sodium that's been reabsorbed in the kidney is going to make its way to the arterioles. An increased amount of sodium in the arterioles is going to cause an increased amount of digitalis-like factor, which is going to stop the sodium pump from working, trapping sodium inside the cell. Essentially, steps 3 through 10 then are going to be upregulated, causing an increased amount of calcium inside the vascular smooth muscle cell, increased actin and myosin interaction, increased vascular contraction, which is going to narrow the lumen space for the blood to go through, and therefore you're going to have an increase in blood pressure. What happens if you have a decrease in aldosterone? So you have a decrease in aldosterone. That's going to reduce the sodium chloride co-transporter, meaning less sodium is going to enter the renal tubular cell wall. At the same time, it's going to reduce the activity of the sodium pump with less sodium moving into the capillary blood. Then you're going to have less sodium that's going to make its way to the arterioles. Less sodium in the arterioles would decrease the release of digitalis-like factor, which means the sodium pump would not stop. As a result, more sodium would leave the vascular smooth muscle cell, and essentially steps 3 through 10 would be reduced. So you would have less calcium that would be entering the vascular smooth muscle cell, less actin and myosin interaction, less vascular contraction, which means now you would have the dilation of the arteriole, meaning there's a greater space for the blood to move through, and therefore you would have a decrease in blood pressure. What happens if you have a decrease in salt intake? A decrease in salt intake is going to cause a decrease in the sympathetic activity, a reduction in epinephrine and angiotensin II release, reducing the sodium hydrogen exchanger 3, which means that less sodium would make its way into the renal tubular cell wall. As a result, you would have less sodium that would be taken up via the sodium pump into the capillary wall, or excuse me, from the capillary wall into the capillary blood. Excuse me, from the renal tubular cell wall, less sodium would move from the renal tubular cell wall into the capillaries. Therefore, you would have less sodium that would make its way into the arterioles. Less sodium making its way to the arterioles would reduce the digitalis-like factor release, and therefore you would have the sodium pump would still be working, allowing sodium to leave. As a result, steps 3 through 10 would be reduced, and therefore you'd have less calcium inside the vascular smooth muscle cell, less actin and myosin interaction, vascular contraction would be reduced, so you'd have dilation, a larger lumen for the blood to flow through, and you'd have a decrease in blood pressure. Well, likewise, if you increase fruits and vegetables in your diet, similar to number 3, and you'd have a decrease in blood pressure because you would presumably have less sodium in your diet. And just like number 3, the same steps would occur: decrease in sympathetic activity, decrease in epinephrine and angiotensin II, a decrease in the sodium hydrogen exchanger 3, less sodium would enter the renal tubular cell wall. Less sodium in the renal tubular cell wall means less would be taken up by the sodium pump into the capillary blood. Less sodium in the capillary blood means less sodium would make its way into to the arterioles, less release of digitalis-like factor, and therefore the sodium pump would continue to work. Therefore, steps 3 through 10 would be reduced. Less calcium would make its way into the vascular smooth muscle cell, less actin and myosin interaction. Again, vascular contraction would be reduced. It would dilate the arterioles, and you have a reduction in blood pressure. What about a decrease in digitalis-like factor? Well, same thing, a digitalis-like factor in the kidneys would reduce the sodium pump, so less sodium would be reabsorbed into the capillaries. Less sodium then in the capillaries would mean less sodium would make its way to the arterioles. Less digitalis-like factor would be present to turn off the sodium pump, so the sodium pump would be active. Therefore, steps 3 through 10 again would be down-regulated, and therefore less calcium would be entering the vascular smooth muscle cell, less actin and myosin interaction, again a decrease in vascular contraction, or you'd have a deep increase in dilation, so there'd be more space for the blood to flow through, and you'd have a decrease in blood pressure. All right, so this is the review of what is happening with an increase or decrease in blood pressure based on these parameters, looking at both the kidney and the arterioles. So again, if you make sure you have a good understanding of this, practice this a few times, go through the questions, match them up, write them down first, and then review them again with this slide.